morning. We're the next engineering. I'm Ephraim.
Zach?
What?
Daddy?
Shin.
Then we're next engineering. This is our robot. His name is Slabs. It stands for Self-Loading Automated Ball Shooter. Yep, this is him. The criteria for the assignment is you have to shoot at least 3 balls 5 inches away from your robot. You can't touch the robot, but you can use tricks, which is cool. There's no restrictions on how many motors you use, how many sensors you use. You're not allowed to use glue or duct tape, and you can use a counterweight. In a robot, we use a water bottle.
Alright, during initial brainstorming, we actually got an idea from a previous robot that we saw at Scorpion. Our first idea was to see if we could take the actual stinger, rotate it into a ball shooter. We knew we needed a platform for that, and then some way of being able to load the ball, obviously, and then to be able to connect the devices so they're not too shaky. So this is a Scorpion arm. We attached 2 motors, so it had a little more power. Created an awesome little holder for the ball. And this was the platform for it. And the ball loader, we kind of attached to it. And our last idea, go ahead next slide, was to be able to connect them. So we all built little pieces and added it all together, and that was the end product.
And we started programming. We actually just built the first part first, where just the arm that shoots it. And so we try to play around with programming and see how far it should move. And we try to think of if we had something to stop the arm so it doesn't overshoot. But what we ended up doing is just having 0.2 rotations on the arm, and then fast this way, and slow going back so it doesn't freak out every time and make all the other balls fall in. So we just had to adjust the speed and how far it went.
We use 3 motors and timing sensors for this assignment. The 3 motors, motor A and C is control the throwing arm, and we use 2 motors because it gives more power to the throwing arms. And motor B is for the feeder arms on the ball loader. It's just a small piece to turn the ball. And the touching sensor is to control the time of the shooting the ball. Yeah, the first picture is how 2 motors connect the throwing arms, and the second one is for the feeder.
So, no project is complete without its problems. Major things we had to deal with were a simple loading system, make sure the unit was stable so that all the force from the motors was being applied, and thus maximizing distance. So we built the Scorpion arm, and it worked great. We got it kind of dialed in and tried several different variables, changing several different variables to see how far we could get it to throw. But then we kind of were at a standstill and we said, well, how does it load? So we started off with having a loader on its own. It's kind of a little platform on its own there, with a single motor using kind of a propeller system. And we just kept adding to that, adding to that, adding to that until it was this wobbly and consolidated mess. And so I think that one of the big issues that we had to deal with was deciding when to develop a current idea or to think of another. And this concept just didn't work out, so we ended up going to a rail. After we built the rail, we had to improve upon our design. We got it to load on its own and work. So we ended up stiffening up the arm itself by adding pegs in between here, increasing the rigidity. And then also we made our ramp a little bit deeper so that when the arm flew forward, the inertia and the force from that didn't kick the balls off of the loading ramp.
Does anyone have any questions?
Okay, yep, thank you.